And welcome back, and it's the Corbett 5 a day higher plus for the 25th of January. Let's go with the first question. Okay, so what do we have today? Prove, right, so it's a proof question, so I need to be very clear in the reasons that I'm using. Often, again, you need to write certain words and be clear. I may not write all those words, I may talk to it rather than write them down, just so you don't have to watch me write lots of words on a screen. But anyway, so prove that the angles in a triangle add to 180. And it gives me a little hint down here. Okay, well, I don't really need a hint, but I'm going to do what the hint says anyway. So if you imagine any triangle, I can turn that triangle around such that one of the sides is level with the floor. You don't actually have to do that, but it just makes it slightly easier to explain. And if I draw a line that is parallel to the floor line, and now I'm going to label the angles of this triangle A, B, and C. Now, what am I trying to prove? I'm trying to prove that the angles inside a triangle add to 180. Well, this is why the parallel lines matter. Because of, let's change the pen color, because of this angle here, which is sometimes called Z angles. Don't ever call it Z angles in an exam, but alternate angles are equal. That means this angle here is also A. And using a similar argument, this is also an alternate angles point, which means that therefore this angle here is C. And if you can see at the top, it must be the case that A plus B plus C is equal to 180 because they lie in a straight line. So therefore I can say A plus B plus C equals 180, and I've proven it to be true. Now, to be clear, I use the word proven there. I haven't written any of this down. If this is a real question, you'd have to write down that angle A equals angle A as alternate angles are equal, etc., etc. Angles on a straight line equal 180, but I'm sure you don't want to see me write all that down. Next question. Okay, what do we have? So it sounds like a bearings question, but I need to draw this diagram clearly. So I've got 4 miles north, and then I'm going northeast. Okay, so I'm going to start here then. So I'm going to go 4 miles north, and then I'm going to go northeast, sorry, by 5 miles. So it's roughly correct. It's a good idea to try and roughly draw it correctly. And then the boat sails back to A. So it goes all the way back down here. So there's my A, there's my B, and there's my C. How far does the boat sail in total? Okay, all right. So what we've got here is we've got a triangle where that angle there is going to be 135 degrees. And why is that? Because the north to east is 90, and then east to northeast is another 45, which gives me 135 in total. And this feels like another cosine rule question. I need to work out that AC in order to work out all the sides together. And AC is going to be cosine rule 4 squared plus 5 squared minus 2 times 4 times 5 times by cos of 135. Put that in my calculator. I'm going to get my calculator out. And I get 8. Now again, I'm going to write a lot of decimal places here because I might use them. 8.323717 ... which means the total distance. So what am I trying to do? How far does the boat sail? Well, it's going to be 4 plus 5 plus that number there. In other words, it's going to add 9. So that's going to be 8.32. Is that the last end of the question? Yes, it is. So I can just write this down to one decimal place. So it's going to be 17.3 units, miles, to 3 sig fig. And that will do for that question. Nice question, as ever. Next one, rationalize the denominator of. Now, this is a technique you need to know how to do. It's often taught near the end of the course, but either way, I've got a surd on the bottom, I've got a plus or minus in the middle, so my technique is going to be to multiply by the same thing, except I change the plus to a minus, or vice versa. Now, I need to do the same to the top and to the bottom, because then they cancel out. And if I do that now, it's going to be slightly messy, isn't it? So let's do this carefully. So the numerator first, let's write it down here. So it's going to be 2 times root 5 plus 2 plus root 3 times root 5 is root 15 plus root 3, and all of that's over root 5 times root 5 is 5 minus 1, which is 4. Okay, yep, and let's just pull all that together. So that's going to be a quarter of 2 root 5, there's no other root 5s, plus 2 plus root 15 plus root 3 And that's it. I can't simplify that anymore. Question done. It's a bit messy, but that's okay. Next question. Okay, this is an interesting one. This is a difficult one because this depends really how your teachers have taught you this, and different teachers do it in different ways. So this is the way that I do it. It tells me that sine x is equal to 5 over 13. In other words, if there's my angle and there's my right angle, sine is opposite over adjacent, which means my right angle triangle is 5, 13. I know from Pythagoras that this side here is going to be 13 squared minus 5 squared square rooted, and it's a common 5, 12, 13 triangle, which means I can write down that cos x, just by looking at my triangle, is going to be 12 over 13. You can see I've left a space. Why have I left a space? Well, because this word here is key. Because the cos curve does this, where this is 90, and because the sine curve does this, well, that's 0 to 180, my angle is somewhere in here, somewhere in what's called the second quadrant. And in the second quadrant, cos is negative and sine is positive, which means this is a negative 12 over 13. It's a difficult question. It's a difficult question, but one you need to be careful of because it has given you all the information, even though it feels it hasn't. Next question, and final question of today. Okay, so I've got a triple bracket, right? The key here is just to be careful. So I'm going to multiply these first two out. I'm going to do it up here so I've got space. So 1 times 1 is 1, 1 times root 3 is root 3, root 2 times 1 is root 2, and root 2 times root 3 is root 6. And then I'm going to multiply all that by 2 minus root 3. Now, I'm going to try and be really careful here just to make sure I match things up afterwards carefully. So let's start, I'll start with a 2, multiply by 2. So I've got 2 plus 2 root 3, 2 plus 2 root 2 plus 2 root 6. So far, not that exciting. Now, if I get a match, I'm going to write it underneath its matching case. You'll see what I mean when I get there. So I've got minus root 3 times 1, which is minus root 3, minus root 3 times root 3, which is minus 3, minus root 3 times root 2, which is plus root 6. Is that right? Sorry, it's minus root 6. And then I've got minus root 3 times root 6, which is root 18, which is the same as root 9 times 2, which is the same as 3 root 2. So I'm going to write this down here as minus 3 root 2. And let's combine all these terms here. So that's going to give me minus 1 plus root 3 minus root 2 and minus root 6. No, sorry, plus root 6 because 2 minus 1 is plus 1. Let's just check that carefully because there's a lot going on there. So 2 minus 3 is minus 1, 2 root 3 minus root 3 is 1, 2 minus 3 is minus 1, and 2 minus 1 is 1. Good, yeah. And that's my final answer, and I'm happy with that one. So let's lock that one in. Nice end to the day. And again, another good mix of questions is starting to bring some different questions here. So I've liked these questions today. Good mix. Usual thing, as ever, like, subscribe, leave a comment down below. Let's try and get that subscriber count up. Thanks, everyone. Bye.